Hello everyone, we are going to do our first lesson of chapter 2. What you should do right now is make sure you have open the student notes so you can follow along in the student notes. If you are taking notes in the student notes, you want to have them printed. If you are taking notes on paper, have out paper. So we're starting chapter 2 now, which is displays of distributions with graphs. So these are some words you probably have seen before in some of your math classes historically. We're going to go through a lot of them over again today. So, for instance, a pie chart. We're going to learn today that a pie chart is used for displaying data that adds to 100%. We're going to make bar graphs, definitely today. We're going to look at line graphs this chapter. We've already seen categorical versus quantitative data. And then we're going to see how rates and counts help us. So, rate and a count, where we start. Often a rate is a fraction, proportion, or percent. It's sometimes more helpful than a count. So what I'm talking about is if I made a small list here and I said, red, blue, yellow, and I was asking people their favorite color, and I just said 14, 8, and 1. These are called counts. This is just how many people answered that question. But if I wanted it as a rate, you will see it's a lot easier to see that 55%, 40%, 5%. If I was to give you just, 14 people like red, 8 people like blue, 1 person likes yellow, that doesn't really help you compare. As opposed to if I said 55% of people surveyed chose red, you would know right away how many people compared to the other ones liked red. It's more of a comparison. So we're going to try and use rates a lot in this class. We're also starting today by just going over some basic vocab words that I'm going to start using some more often in class. So the first thing I'm going to use a lot is the word a distribution. A distribution is all of the values a variable takes. So if I said to you, what's the distribution of months in the year? We would answer January, February, March, April, etc. It's basically all the outcomes a variable could take. I'm also going to start using words like, let's look at the trend on the graph. A trend on a graph is basically saying the overall pattern, upward, downward, over time of a graph. Deviations is a word we are going to use a lot in this class, and it's going to usually mean anything that's an unusual feature. If you look at a graph and one thing stands out or one point is not like the rest, we're going to call that a deviation from the rest of the graph. These last two we don't use all that much, but they're important to think about. Sometimes when you look at a variable, things can change by the season. For instance, gas prices. In the winter, they charge you more for gas than in the summer. And in the spring and fall, it's the cheapest of them all. It's called seasonal variation. When the demand is high, the price goes up. When the demand is low, the price goes down. So we're just going to use, most of these words are going to be distribution, overall trend, and deviations, which we're going to call unusual features. So these are some vocab words to get us started before we can really get into it. What we are looking at today is mostly how to make good graphs. And I want to really focus on these first few. Whenever we make a graph in this class, please, please, please keep in mind you're going to be earning points for how you label the graph and if you need a legend, but mostly you want to label your graphs clearly. You want to make your data stand out. You don't want to make an awful looking graph where the data is really tiny or the graph lines are way too big and it doesn't make any sense. So what we're going to do is pay attention to always what the eye sees and try and make good graphs off of that. Leading off that pay attention to what the eye sees, I start with this graph. What kind of graph is this? Well, it's a pictogram, meaning, what is it? This is saying, what is the purchase power of the Canadian dollar? Meaning, how much is the Canadian dollar? In Canada, a dollar is a gold coin like this. What is a Canadian dollar worth compared to a US dollar. That's what this is saying. So it's saying in the year 1990, a Canadian dollar was worth $1 US. And in the year 2000, a Canadian dollar was only worth 46 cents US. And I want to lead you into this because I want you to think about what on this graph might be misleading. Well, the fact that it's a pictogram is what we always have to look at. So let's see this on raw data. We'll just look at the first and the last. This is $1. This is 46 cents. Or better yet, we have 50 cents and we have $1. What is the relationship between 50 cents and a dollar? 50 cents is 1/2 of what a dollar is. So if I look at this picture and I look at this picture, does anybody see in their heads what is misleading about those coins? The misleading point is that they chose to make the radius of the circle half of the radius up here. So they said, okay, $1 here, so this is $1 radius. 50 cents here, this is a 50-cent radius. But why is that misleading to the eye? Because when you think about a radius of a circle, the area of the circle gets 4 times bigger. So this area is 4 times this area. So is that misleading? Absolutely. It looks like in 1990, the Canadian dollar was amazing. But then when you got to 1995, the dollar was worth looks like nothing. When really they said, oh, it's really worth half, but let's make the picture 4 times smaller. We're going to try and not make those mistakes in this class, and we are going to try and make good graphs. So when we look at a graph, we are going to try and look at a graph and look for some very important general features of a graph. Now, I like to call it C-U-S-S. Cus. We look for the cus of a graph. So what we're going to do is we're going to develop what each one of these letters means in this chapter. But for right now, we are going to look at the overall shape of a graph. So one of the letters in cus stands for shape. One of the S's is for shape. When we look at a graph, we're going to look at a bunch of graphs this chapter. We're going to start by describing that distribution. So we are going to look for the overall pattern and striking deviations, meaning we are going to look for the shape and striking deviations. That word is going to be linked to outliers, or what we are going to call it unusual features. Unusual features of a graph. We're going to call it outliers. An outlier is an individual observation that falls way outside the pattern of the graph. So what we are doing is we are looking at what we started with the vocab. We're looking for the trend of the graph. So we're looking for the shape of the graph. And then when we look at a graph, we're always going to look and see if there's any single or a couple of points that are far away from the rest, and we think that they are big deviations or unusual features on the graph. So in dealing with cus, what we're going to build on this whole time, we're going to look for C. U is for unusual features. We are going to talk about shape right now, and we are saying that we are also going to have a letter spread. So spread and shape are the 2 S's. What we're going to do on this slide is just look at shape. We're looking at the shape of a graph. And luckily, when you answer a question in this class, shape can only be 3 answers. You can say the distribution is symmetric in form, or it can be skewed to the right or skewed to the left. Only options for shape. What we have here on this graph right now is 3 pictures, and each of them is called a histogram. We're going to learn more about what a histogram is, but for now, let's just say it shows the overall distribution, and from it, you can easily get the shape. So our red graph up here, let's take a look at the overall shape. It looks to me like the graph kind of goes up and down. And in general, the graph kind of has a mirror on the left and it mirrors on the right, meaning from the center, it looks basically the same on the left and right. That is going to be called approximately symmetric. It'll be a symmetrical graph. Same on the left, same on the right. What we are going to look at also are these two types of graph, where they have skew. It's definitely not the same on the left and right of these graphs. Now, the hard part is deciding right versus left, but it's really not that hard. When we look for the shape of a graph and you see a tail that heads to the right, meaning a lot of extra data on the right, we are going to call this skewed right, or skewed to the right. Skewed right, because the extra data is on the right. If you look at this other graph, most of the data is right here. That's where the majority of the data is. But then the tail sweeps left. So this graph will be skewed left. So this overall makes up the only options for shape when we're doing this. Shape can be roughly symmetric, skewed to the right, extra on the right, or skewed to the left when extra is on the left. We are describing graphs. Now, we are also going to make our own graphs, and we start today with the stem plot. We've seen a dot plot before. Now we make stem plots. You've also maybe heard these as stem and leaf plots. A stem and leaf plot we are going to use when we have smaller data sets, and it gives you more detailed information than our dot plots. So it's a three-step process. All we have to do is separate each observation into its stem and its last digit. So if I had, I'm going to put up some numbers. So I'm going to show you what a stem and leaf is. First, if I had the number 19, if I had the number 1081, and if I had the number 7.9. No, we'll say 17.9. If I was going to separate stems and leaves, the stems I will put in the red. Stems will be red. A stem is every digit except the last one. So it is the 1, the 108, and the 17. A leaf is only the final digit. So a 9 would be a leaf, the 1 would be a leaf, or even though there's a decimal point, the 9 would be a leaf. And then what we do is once we separate stems and leaves, it says to make a vertical column of the stems and put the leaves in order. I'm going to show you what that means. I'm going to show you how to make a stem and leaf plot. We're going to use this data first. I'm going to make a stem and leaf plot. Now we will come back to splitting the stems, so we won't use this one yet. I want to show you just what a stem and leaf plot consists of. So what I'm going to do is I'm going to make my own stems here. Perfect. So to make a stem and leaf plot, you make a vertical line up and down. And then you look at the data and you see where are the stems. So I have 2s, 3s, 3, 3, 3, 4, 3, 3, 2, 3, 3, 4, 3, 2, 3, 4, 3, 3, 4. So I have 2s, 3s, and 4s. So my stems are 2, 3, and 4. Then I make a vertical line. Now what you do is you fill in the leaves wherever they go. So I have 29, so I have a 9. I have 27, so I have a 7. Look at what's happening. The stems are the first digit. So this is our 20s. 29, 27. Done, done. I have a 36 and a 36. So 36, 36, and then 36, 36. So this is our first digit. This is our last digit. 34, 39, 39, 41, 36, 36, 24, 39, 40, 38, 35, 40, 37, 27, 33, 40, 34, and 39. So what I did was I separated stems and leaves and then just put all the leaves where they would go. So again, how you read this is your stem. This is the 20s. So 29, 27, 24, 27. So it's very quick to see the numbers. But a stem and leaf plot is not finished like this. A finished stem and leaf plot, you take the leaves and you put them in order from smallest to tallest. So 4, 7, 7, 9. 4, 7, 7, 9. Threes, what did I have in the threes? A lot more, so you have to go nice and slow. I definitely have a 3. Then how many 4s do I have? I have 1, 2 4s. 4, 4. Then do I have a 5? Yes, I have a 5. Then 6s. 1, 2, 3, 4 6s. So I put 4 6s. 1, 2, 3, 4 6s. Then I have an 8 and 4 9s. 8, 9, 9, 9, 9. And then I have 0, 0, 0, 1. This is a finished stem and leaf plot right here. You have all your stems, and you can see the smallest number in this data set is 24. The highest is 41. You can also see that the data is really focused in the 30s. So you can see here that the data has basically that nice symmetric shape from 20s to 40s. It bounces up and down. If you look at this, it bounces up and back down, so symmetric shape. And again, the stem and leaf plot is to see the data ordered. See how nice it looks ordered? 24, 27, 27, 29, 33, 34. How quickly it becomes ordered by making a stem and leaf plot. Very practical tool for small data sets. On the same data, we could do something called splitting the stems. So what that means is, instead of having all of the 20s be next to the 2, I can split the stems by saying this will be the 20s, but it'll just be for 0 through 4. So this would be for numbers 20, 21, 22, 23, 24. The next 2 would be for 5 through 9. 30s can go from 0 to 4, and then another 3 for 5 to 9. And then the 40s, I don't have a lot of them, so I could just need the 0 through 4. So now what we can do is we can take the same data, but we can split the stems. So if you look at all of our 20s, I have 29, 27, 24. I have, we can make it the same way. So I have my 2, 2, 3, 3, 4. And I'll just put the data in. I have a 9, so that's in the second 2. A 7 is in the second 2. Then I have a 36. 6 goes in the second. 36 in the second. 34 goes in the first. 39 in the second. 39 in the second. 41, 36, 36, 24. 39 and 40. 39, 40. 38. 35. 5 to 9 is in the second one. 40, 37, 27, 33, 40, 34, and 39. Now I put these in order, and then I made a split stem plot where you can see the data is not so clustered. So 7, 7, 9. 30 had, what's my lowest? So 3, 4, 4. 3, 4, 4. Then I have a 5. And then I have 4 6s. 6, 6, 6, 6. Then I had an 8. And then 4 9s. 9, 9, 9, 9. And then 40 is 0, 0, 0, 1. So splitting the stems is when you take one digit, and it helped us for the 30s. When you had way too many 30s, it might help to say take the first half of the 30s and the second half of the 30s and split them. It still shows you this distribution goes up and down. It's a nice symmetric distribution. It still shows you all of the data points from smallest to tallest, but you split the stems. We don't often split the stems, but it's good to know. What I'm going to do is finish this video by showing you one more stem and leaf plot from the textbook. I'm not going to make it from scratch, but look at this. Here it is. Here is the percent of residents age 65 or older in every state. So what this means is Alabama has 13.5% of its residents are over 65. So if I wanted to make a stem and leaf plot out of this, the last digit is the only leaf. The stems are all of these first two digits, like 7, 12, 14, 11. They're all stems. So let's go over how we would make it. Here's the steps. First, we separate the stems, and the leaf would be the decimal. Then I'm going to write out all of the stems. Let's show you how you find the stems. The stems go from what is the smallest number, in this case 7, and then what is the highest stem. The highest stem I think is down in Florida. Yes, 17. The highest number here is 17, the lowest is 7. So my stems go 7 through 17. Then you take the decimal for each of these, like 13.5. And you can see here they went to 13, and the first one they had was a 5. And you place all of the leaves where they go. Finally, the third step in every stem and leaf plot is to take each one of these rows and put it in order from smallest to tallest. They did not split the stems here. We don't often split the stems. But what you see here is I can very quickly see this distribution has, again, symmetric shape. Look at that. Bounces up, bounces back down. Very symmetric here, from low to high to low. I also can see the lowest is 7, the highest is 17. The data spreads from 7 to 17. And I can see there's a lot of states that have 11 to 14% 65 and older. A stem and leaf plot is way better than looking at this giant table. It summarizes the data so you can quickly see the low, the high, and what the shape of the data is. So what we're going to do now is we are going to go and we are going to do some book exercises together where we discuss some of these ideas with a stem and leaf plot. We're going to make some bar graphs. We're going to look at some line graphs. So idea is we're going to move on today and we're going to look at all ways of visualizing data. So head back to the Zoom and we're going to continue.